In this video, we are going to explore the dodSON.Core Component Management namespace. The dodSON.Core Component Management namespace, utilizing virtually every namespace in the dodSON.Core library, provides all the functionality to create a configurable, package-deployed, plugin-based distributed programming framework. To achieve this, the dodSON.Core Component Management namespace introduces the concepts of controllers and components. Each configurable controller is responsible for a single primary function, which are packaging, installation, logging, networking, and component control. Each controller is built using the types from their respective dodSON.Core library namespaces. Components are either extensions or plugins, built using the types from the dodSON.Core.Addon namespace. The component manager supervises and coordinates the controllers to provide a stable framework where components are packaged, installed, and started, and then provided with configuration, logging, and networking services pre-configured and ready to use. In the following example, we will instantiate a component manager from a configuration file. When started, it will install 3 packages with 1 component each, 1 extension, and 2 plugins. Each component has been designed to log any messages received and then to reply directly to the client sending the message with a new message. This will set up a simple message oscillation between the clients. A custom log filter has been provided which can be configured to filter any number of log source IDs. We will add this custom log filter to a log splitter and create 4 logs, 1 for the component manager and 1 each for the clients. First, let's go over the component manager's configuration file. It contains the type of the component manager to be instantiated and the log source ID used when the component manager generates logs. It also contains subgroups for each of the controllers. The communication controller configuration defines the types for the server and the clients, the server channel information, and a transport controller configuration. The transport controller configuration contains a registration controller, which itself contains a challenge controller, and a transport configuration, which contains the information used when transporting envelopes between servers and clients. See the Programming with the dodSON.Core Networking namespace video for more information about networking. The component controller contains the file name of the custom configuration file and the serializer type used to serialize and deserialize the custom configuration file. The custom configuration file is a second configuration file which can be used by the developer to create more configuration information. It is a fully supported object with read and write functionality for both packages and installed packages built into the component controller. The folder access items defines a set of named directories, making it possible to find specific paths by using keys. The installer contains the file name of the package configuration file and the serializer type used to serialize and deserialize the package configuration file and the directory to install packages. The installation settings define how to install packages. See the Programming with the dodSON.Core Packaging and dodSON.Core Installation namespaces video for more information about installing packages. The log controller defines a file store used to archive logs, the actual log, and then a group of log controller settings which defines how the log controller will behave. A closer examination of the log controller's log group shows that it is a log splitter with 4 log filters. Each log filter contains a log and a log entry validator. The log defines where to write the logs, and the log validator, the custom log filter multi-splitter, defines any number of log source IDs which will be written to the corresponding log. See the Programming with the dodSON.Core Logging namespace video for more information about logging. The package provider contains the file name of the package configuration file and the serializer type used to serialize and deserialize the package configuration file and a package file store provider type, which is used to access packages in the package file store. It also defines the file store where the packages are stored. See the Programming with the dodSON.Core Packaging and dodSON.Core Installation namespaces video for more information about packaging. We will use this configuration to instantiate a new instance of the dodSON.Core Component Management Component Manager. See the Programming with the dodSON.Core Configuration namespace video for more information about creating configurations and instantiating types from configurations. Examining the code, we will first look at the multi-splitter. It implements the dodSON.Core Configuration configurable interface, which means that it can be instantiated from a configuration. To configure an instance of the multi-splitter, we simply iterate all items that start with source ID and add them to a list. In the isValid property, we return true if the candidate log entry's source ID is in the list. It generates a configuration by adding a type of type for this type and all of the items in the list. The component extension alpha inherits from the abstract base class dodSON.Core.ComponentManagement component extension base, which allows it to run in the same application domain as its host, and overrides the required properties and methods. The component designation and the component name are part of the component designation discovery system, which facilitates discovery of components on a network. The client configuration allows the component to configure its network client. The onComponentStarted method is called whenever the component is started, and the onComponentStopping method is called when the component is stopped. And the onMessageReceived method is called whenever a message is sent to this component's network client. The component extension alpha's onComponentStarted method will log that the component has started and then wait 5 seconds to send a seed message. Its onComponentStopping method will log that the component is stopping, and its onMessageReceived method will log that the message was received and sends a message directly back to the client that originated the message. The plugins plugin beta and plugin gamma inherit from the abstract base class dodSON.Core Component Management component plugin base, which allows it to run in a separate application domain as its host and overrides the required properties and methods. The component plugin beta's onComponentStarted method will log that the component has started, and its onComponentStopping method will log that the component is stopping. Its onMessageReceived method will log that a message was received, waits 2 seconds, and sends a message directly back to the client that originated the message. The component plugin gamma's onComponentStarted method will log that the component has started, and its onComponentStopping method will log that the component is stopping. Its onMessageReceived method will log that a message was received, and then it will send a message directly back to the client that originated the message. These components have already been compiled and put into packages. Examining one of the packages shows that the dodSON.Core assembly and the components assembly have been added along with a package configuration file. The package configuration file defines the properties of the package. The other packages are similar. See the dodSON.Core library help file for more information about creating and configuring packages. Looking at all the packages configuration files, we can see that each of them defines a priority. When the configuration manager starts packages, it will always start extensions before it starts plugins. Within the group of extensions and the group of plugins, however, the packages will be started based on their priority. The lower the priority, the earlier a package will be started. This means that extension alpha will be started first, because it is an extension. Then, between the two plugins, plugin gamma will be started before plugin beta, because it has a lower priority. When stopping extensions and plugins, the opposite is true. Plugins will be stopped first, then extensions. Within each group of extension and plugins, the priority logic will also be reversed. The highest versions will be stopped before the lower versions. This supports a level of service availability by ensuring that services that are required by other services will be started before those services that depend on them are started, and that the dependent services are stopped before the services that they require are stopped. In the main application, we will start by loading the Component Manager demo configuration file and using an XML configuration serializer to deserialize it into a configuration. We will then use that configuration to instantiate a new component manager. See the Programming with the dodSON.Core configuration video for more information about serializing, deserializing, and instantiating configurations. Next, we will check to see if the component manager is running. Start the component manager, and again check to see if it is running. Once the component manager is running, we will continuously display the component manager's runtime and wait until the user presses any key. We will then stop the component manager and again check to see if it's running. Finally, we will wait for the user to press any key, allowing them to view the results. Compiling and running the application shows the component manager is not running, the component manager starting, and finally that it is now running. We will let the component manager run for 1 minute. We will stop the component manager and show that it is not running, and then wait for the user to press any key. We can see here that the packages were installed and that 4 logs were generated. Opening the system log, we can see that the component manager was started, which versions of .NET and the dodSON.Core are being used, the executable path, the package store information, and the installed packages information. Next, we see that the communication controller has started. It has created and opened a named pipe server and registered an internal client. Next, we see that the installer has started. It displays the directory where it will install the packages and lists all of the packages it found. Then it proceeds to install the packages in no particular order. Once all of the packages have been installed, the installer will list the installed packages. Finally, the component controller will start. It lists the extension components and the plugin components in the order in which they will be started. All extensions will be started before plugins. Since extension alpha is an extension, it will be started first, followed by the plugins. All components, both extensions and plugins, within their respective groups will be started based on their priority. The lower their priority, the earlier the component will be started. The package configuration for plugin Gamma has a priority of 500, whereas the package configuration for plugin Beta has a priority of 1000. Therefore, plugin Gamma will be started before plugin Beta. As each component is started, you can see that they have their clients registered with the network. This completes the initialization and starting of the controllers by the component manager. The component manager is now running. After letting the component manager run for 1 minute, we pressed any key and stopped the component manager. The component manager will first stop the component controller, which will stop all of the components. Stopping the components is the reverse of starting the components. We will stop the plugins first and then the extensions. Within the groups of plugins and extensions, we will stop each component in reverse priority order. As each component is stopped, its client is unregistered from the communication system, displaying some basic statistics. Once the component controller is stopped, the communication controller is stopped. First, it unregisters its internal client and any other clients that have not been unregistered, and then displays some basic statistics. Communication controller only deals with envelopes, therefore, only the incoming and outgoing bytes and envelopes are displayed. Once all of the component manager's controllers are stopped, the component manager is finished and logs its total runtime and how many logs it generated. Now we will look at the extension alpha log. It shows extension alpha starting and that it is running in application domain 1. This is because it is an extension and is running in the host applications domain. Extension alpha does not receive the seed message because extension alpha sent the seed message and has been configured not to receive its own messages. We can see, however, that messages are being received from plugin Gamma and plugin Beta. There are twice as many plugin gamma messages as there are plugin beta messages because plugin beta waits 2 seconds before responding to a message. Finally, we can see that extension alpha was stopped. Looking at the plugin beta log, we can see that it was started and is running in application domain 6. This is because it is a plugin and is running in a different application domain than its host. We can see that it received the seed message from extension alpha and then receives only messages from extension alpha. This is because the components have been programmed to respond directly to the clients that sent the message, in this case, extension alpha. Looking at the plugin gamma log, we can see that it was started and is running in application domain 5. This is because it is a plugin and is running in a different application domain than its host. It has a lower application domain ID because it was started before plugin beta. We can see that it received the seed message from extension alpha and then receives only messages from extension alpha. This is because the components have been programmed to respond directly to the clients that sent the message, in this case, extension alpha. The dodSON.Core Component Management namespace provides a feature-rich framework for a configurable, package-deployed, plugin-based distributed programming framework, making it easy to create configurable extensions and plugins that are provided with configuration, packaging and installation, logging, and advanced communication systems. Please see the dodSON.Core library help file for more information.